Look at our schedule. We're going to talk about dividing polynomials and the factor theorem today. I forgot after I canceled class last Friday to change your homework due dates. So you might have been working on this up for today and been like, I have no idea what I'm doing. I changed the due date, so it's actually due Monday now because we're going to cover it in class today. So all the rest of the due dates are correct. Upcoming assessments, we have a quiz, a take-home quiz I'm going to give you next week. I'm going to give it to you on Wednesday. It's due on Friday. And then the following week, project 3 is due. Project 3 is it's green. It's on green paper. It's just a front and a back. Okay, so today we're going to talk about division of polynomials. Okay. So in order to be able to divide polynomials, we're going to have to remind ourselves how to divide regular old numbers. Okay. We're going to use the long division algorithm that many, if not all of you, probably learned in 4th, 5th grade, somewhere around there. So you may have completely forgotten it. So we're going to remind you how it works before we start to try it on polynomials. All right, so I want to do 11 into 787. Okay, so how many sets of 11 can go into 787? Okay, so yeah, what's the first thing you do? You try to fit 11 into 7. You look at just the leading number, right? Does 11 go into 7? No, so you go one more over and you look at 78. Does 11 go into 78? Yes, how many times? 7 times, so I put a 7 up here, right? And then you multiply 7 times 11, right? 77, and you write that underneath. Then you subtract. Leaves you 1. Yep, 78 minus 77 is 1. Bring down the 7, you get 17. Okay. Then you start again. Then you start with the 11 and say, does 11 go into 17? Yes, once. So I put a 1 up here. Then you do 1 times 11, you get 11. You subtract. 17 minus 11 is 6. Does 11 go into 6? No, I'm done. So that's my remainder, right? And the way you deal with your remainder, probably the year after you learned long division, is you learned to deal with the remainder by putting it over the divisor. So my final result, if I want to do 787 divided by 11, I get 71. And then we have a remainder of 6, and you do that by doing 6 over 11. So it goes in 71 times 71 and 6/11. R, yeah, yeah. So maybe a year or two after you do it with just writing the R6, you change it to a fraction. I've never seen that. Okay. Well, that's how you do it. Yes, and 0.5454 repeating is 6/11. Yeah, you can do it with decimals too. Yep. But we're going to do it with the fraction today. Okay, so I want to rewrite this polynomial. This is going to help us when we start dividing polynomials. I want to rewrite this polynomial in descending powers of x. That means the highest power of x, the next highest power, the next highest power. So I'm going to have 6x cubed. That's my highest power of x. My next power is x squared, so I have a minus x squared, because the sign that's right next to a term is glued to it forever, right? So I have positive 6x cubed. It will always be positive 6x cubed. Then this is a minus x squared. So I write minus x squared. My next term is my x term. It's minus 5x. And my last term is a 4. There's no sign, so you assume it's positive, so we write plus 4. Okay, so the last thing is I have a division problem. I wrote it as a fraction, but that's really says that 2x cubed minus 3x squared minus 11x plus 6 divided by x minus 3 equals 2x squared plus 3x minus 2. Okay. So I want to use that fact to factor 2x cubed minus 3x squared minus 11x plus 6 completely. So division and multiplication undo each other, right? So looking at this equation, I'm going to multiply both sides of that equation by x minus 3. So on the left, the x minus 3's cancel. And I have 2x cubed minus 3x squared minus 11x plus 6. And on the right, I'm going to have x minus 3 times 2x squared plus 3x minus 2. So I factored it, right? Because by knowing that division problem, I was able to factor the cubic into 2 factors. Can I factor any further? I don't know if 2x squared plus 3x minus 2 factors. Let's see. I'm just copying the x minus 3 for now. This might be futile, but if I want to factor 2x squared plus 3x minus 2, I've got to have 2x and x, right, to get my 2x squared. My outer and inner terms would have to add to 3. So if this was a 2 and this was a 1 plus and minus, then I'd have 4x minus x. That gives me 3x and then minus 2. So that works. I just did that by trial and error. I just did all the trials in my head. So you might have to write some down. Okay, so that's like a good little intro to our division day. Okay. Division of 2 polynomials can be done using an algorithm that's really similar to long division of 2 natural numbers. I'm going to start by looking at the long division problem we just did, the 787 divided by 11. But I'm going to write it out a little bit differently. Okay. So 11 is actually 10 plus 1, and 787 is actually 700 plus 80 plus 7. So I'm breaking this all up into like place value, hundreds, tens, and ones. And so I'm going to do a similar thing that I did when I looked before. I said, does 11 go into 7, the 7, right? That was my first question. Does 11 go into 7? Yes, in this case, we're going to look and see how many 10s go into 700. How many 10s go into 700? 70, yep. Okay, and then I have to multiply 70 times this 11, right? But I'm actually going to use the distributive property. So I'm going to do 70 times 10, and I get 700, plus 70 times 1, which is 70. So that's still 70 times 11 is 770. And then I subtract, just like I did in the regular algorithm. 700 minus 700 is 0. 80 minus 70 is 10. Bring down the plus 7. So then I ask myself, how many times does 10 go into 10? Once. So I do plus 1 up top. Then I have to multiply my 1 times my 11. But I wrote my 11 in a weird way. So it's at really 1 times 10 plus 1 times 1. So 1 times 10 is 10. 1 times 1 is 1, and I subtract. 10 minus 10 is 0. 7 minus 1 is 6. That's my remainder. So here, maybe I'll use my remainder value here, right? So this says that 787 divided by 11 is 71, remainder 6. So I get the exact same thing. I was just wrote everything out by place value. And then to check, I should be able to multiply things to get back to where I started. I should be able to multiply my 71 times my 11 and get the original number I started with. Okay, so if I do quotient was my 71 divisor was 11, and add my remainder of 6, I should get 787. Okay, so that's a way to check. So we should note that 11 is not a factor of 787. It doesn't go in evenly, right? So because the remainder was not 0, that's how we can tell that. Okay, so this may all seem a little obvious, but let's do, I'm going to replace all my 10s with x's. Okay. So I'm going to rewrite this as a division of 2 polynomials. By every time I have a 10, I'm going to actually make it an x. So this is x plus 1. How could I rewrite 700? 7x is only 70. How do I make 700? 70x, but I don't want, but I could rewrite 70 as 7 times 10. So it's like 7 times 10 times 10. 7x squared. Yeah. That's my 700. Because 10 squared is 100. Okay, so it's 7 times 100, 700. Okay, 80 is 8 times 10, so 8x. And then 7 is just the 1s. There's no 10s there, so it's just plus 7. And then I do the exact same algorithm I just did on the left. Okay, just look at the x and say, what should I multiply x by to make 7x squared? 7x. So I put a 7x up here. And I multiply. 7x times x is 7x squared. 7x times 1 is 7x. And then I subtract. 7x squared minus 7x squared is 0. 8x minus 7x is 1x. Bring down the plus 7. Then you do it again. You say, okay, what do I multiply x by to make x? 1. So I've got a plus 1 here. And then I multiply 1 times x plus 1. You can think of it as distributing. 1 times x plus 1 times 1. So 1 times x is x. 1 times 1 is 1. And subtract. X minus x is 0. 7 minus 1 is 6. So instead of getting 70 plus 1 as my answer, I got 7x plus 1 because x is 10 here. Same remainder, 6. And then it should be that when I multiply this guy times this guy and add the remainder, I get my original dividend back. So let's just check. I do x plus 1 times 7x plus 1 plus 6. I should get 7x squared plus 8x plus 7. So if I multiply this out, I get 7x squared plus x plus 7x is plus 8x plus 1 plus 6. 7x squared plus 8x plus 7. Check. Okay, let's do one more together, and then I think after that you'll be able to try some on your own. Okay, so I want to divide 6x squared plus 5x minus 6 by 2x plus 3. So the first step is to arrange the dividend in descending order. That's already done. Okay. And the divisor in descending order, already done. So step 2, I'm going to write this out as 6x squared plus 5x minus 6 divided by 2x plus 3. So you look at just the leading terms, the 2x and the 6x squared. And you ask yourself, what do I multiply 2x by to make 6x squared? 3x. So I put a 3x up here. And then you multiply 3x times 2x plus 3. And you have to multiply that 3x times both terms. Pretend those are in parentheses and you have to distribute it. Okay? So 3x times 2x is 6x squared. 3x times 3 is 9x. And then you subtract. 6x squared minus 6x squared is 0. 5x minus 9x is negative 4x. Bring down the minus 6. And then you start again. You say, okay, what do I multiply 2x by to make negative 4x? Negative 2. So then I distribute my negative 2 to my 2x plus 3. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. And I subtract. Negative 4x minus negative 4x is 0. Negative 6 minus negative 6 is 0. So I get a remainder of 0 here. The 9x, that came from taking my 3x and multiplying by the 3. I had to do 3x times 2x, that gave me 6x squared, and then 3x times 3, that gave me the 9x. So is 2x plus 3 a factor of 6x squared plus 5x minus 6? Yes, because we got a remainder of 0. So it should be that if I multiply these two guys together, I should get the original dividend back. Okay, so let's just check that that works. 2x plus 3 times 3x minus 2. So a foil or lobster claw, or however you learned how to do this. 2x times 3x is 6x squared. Minus 4x plus 9x is plus 5x minus 6. That was my original divisor. So the handy thing about division is you can always check by reversing and doing multiplication. Questions on here? All right, let's move on and then we'll come back if we need to. So polynomial long division, you can check by multiplying. This is called the division algorithm. If you multiply the thing you were dividing by times the answer and add the remainder, you get the original dividend, the thing under the division symbol. Okay, so here I've got a picture of a polynomial function f. You can see it has zeros at x equals negative 2. Right here, it crosses the x-axis at negative 2, 1, and 3. So real zeros are just another word for x-intercepts. So we've got x-intercepts at negative 2, 1, and 3. They all have multiplicity of 1. How can you tell? They go through the axis, and they kind of look like a line. They don't flatten out as they go through. Okay, so then what are the factors of f, right? So if I know the zeros, I know the factors. What are the factors? Yeah, those are zeros, yeah. So remember the way that you find zeros algebraically? Yes, yeah. X plus 2, x minus 1, and x minus 2. I mean 3. Right, so the way we algebraically found zeros was we took our function and we set it equal to 0 and we try to solve it. And when you have 3 factors, answer is 0, you can set each factor to 0 separately. So if this one gave you an x equals negative 2 as the answer, it has to be that what was in parentheses was an x plus 2. Right? You subtracted 2 from both sides to get the solution. Right? So if x plus 2 is a factor, that means that negative 2 is a 0, right? Okay, so x plus 2 is a factor, x equals negative 2 is a 0. Those are like synonyms, some different ways of saying the same thing. So that means that if I plug negative 2 into the function, I get 0. That's what it means to be a 0. So if x minus 1 is a factor, that means that f of 1 is 0. And if x minus 3 is a factor, that means f of 3 is 0. and vice versa, right? If f of -2 is 0, that means x plus 2 is a factor. Okay, so if you know a factor, you know a 0. If you know a 0, you know a factor. If f of 1 is 0, x minus 1 is a factor. F of 3 is 0, you know x minus 3 is a factor. So this is what we summarize as the factor theorem. If c is a 0, x minus c is a factor, and if x minus c is a factor, f of c is 0. All right, so here's a cubic polynomial, 2x cubed minus 3x squared minus 11x plus 6 equals 0. I'm telling you that negative 2 is a 0. That means that if you plug -2 in for x, you get 0. X equals -2 is a 0. X equals -2 is a 0. So I want to use that fact to factor f of x. So if if -2 is a 0, that means that f of -2 equals 0. That's the definition of what a 0 is. And that means what is a factor? If -2 is a 0, what is a factor? X plus 2. Great. So I'm going to use that factor and long division to find the other factors. Yeah, so I divide 2x cubed minus 3x squared minus 11x plus 6. Divide by the factor I know, x plus 2. The result will be another factor. So this is a good opportunity for us to go through this algorithm one more time together. Just look at the leading term, the x and the 2x cubed. What do you multiply x by to make 2x cubed? 2x squared. So we write that up top. Then you multiply that 2x squared times the x and the 2 of the dividend. So 2x squared times x is 2x cubed. And 2x squared times 2 is positive 4x squared. And I have to subtract. So 2x cubed minus 2x cubed is 0. Here it's a little tricky. Negative 3x squared minus 4x squared. Close? Negative 7x squared. Bring down the minus 11x. And then you start again. You go back to your x plus 2. We just look at the x. You say, what do I multiply x by to make negative 7x squared? Yep, negative 7x. And then multiply x plus 2 times negative 7x. You get to multiply by the x and the 2. So negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x, and subtract. Negative 7x squared minus negative 7x squared is 0. And then again, be careful with your subtraction sign and your negative sign. This says negative 11x minus negative 14x. 3x. Yeah, so it's actually negative 11x plus 14x, which is 3x. Then bring down the plus 6. Everybody see where that 3x, why that comes out as 3x? Okay. All right, then we start again. We just look at the x and say, what do you multiply x by to make 3x? 3. So I have plus 3 over here. Multiply 3 times your x plus 2. So 3 times x is 3x. 3 times 2 is 6. Subtract, and you get 0. So I now know that I already knew x plus 2 is a factor. So I was expecting to get 0 as my remainder. Okay, and I now know that I can rewrite f of x as x plus 2 times 2x squared minus 7x plus 3. That equals the cubic polynomial that we started with. And then can you factor that quadratic any further? I'm not sure. X plus 2, I'm just going to try and see if I get anywhere. To get 2x squared, I've got to have 2x and x. I want them to multiply to be a negative, to be positive, but add to be negative, so I got to both be negatives here. So 3 and 1, that'll work, because that gives me negative 6x minus x and plus 3. So that is the completely factored form of f of x. Okay. And then what if I also wanted all the zeros of f of x? They're right there. What are they? Negative 2 and 3 is correct. Yeah, you have to set that factor equal to 0 and solve it, and you get 1/2. Okay. So pay attention to what's being asked for. If they ask for factors, you write it out as the bubbles, right? And if they ask for zeros, the answers are just numbers. But if you know a factor, you know a zero, and if you know a zero, you know a factor. So you just have to be aware of what they're asking for. All right, so that was the last example. Any questions? Mm-hmm. To find zeros or to find factors. Yep. All right, try it.